Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's problem is DFA example problems. Draw a DFA for the language accepting strings starting with A over input alphabet A comma B. Here, input alphabet is A comma B. The first symbol should be A. Remaining symbols combination of A's and B's, combination of A's and B's. Valid strings are A, B, A, because first symbol is A. A, first symbol is A. A, B, first symbol is A. Last symbol may be anything. From second position, the symbol may be anything. The first symbol must be A. Invalid strings are B. The string begin with B. After that, you can see any combination of A's and B's is invalid. If the first symbol is B, after that no need to see the next symbols. Initial state is the Q naught. If the first symbol is B, I can go to dead state, because if you see first symbol as B, afterwards if you read any number of A's and B's, that is invalid. So that I can go to dead state, there I can read any number of A's and B's, stay in the dead state. You cannot come out from the dead state, because afterwards we have any symbols, that is invalid only. I have already seen first symbol as B. If the first symbol is A, I can go to final state, because the string should begin with A. So, if you see in Q naught, first symbol is A. In Q naught, if you read A, that means first symbol is A. So, that is valid string. Afterwards, you can read any combination of A's and B's, stay in the same state, Q. This is the diagram, transition diagram for DFA. Transition table is like this. Q naught is the initial state, Q1 is the final state, another non-final state is dead state. Q naught on 0, Q naught A, B, okay. Input is A, input is B. Q naught on A going to Q1, Q naught on B going to dead state, Q1 on A going to Q1, Q1 on B going to Q1. Dead state, from dead state for any number of A's and B's, stay in the same state, dead state. Draw a DFA for the language accepting strings starting with 101 over input alphabet 0, 1. So, starting with 101, first three symbols in the order 101, afterwards any combination of zeros and ones. So, valid string 101, after that you can get any combination like that. Invalid, is invalid. First three symbols must be in the order 101. Q naught is the initial state. If the first symbol is 0, the first symbol must be 1. If the first symbol is 0, I can go to dead state. There itself we decide that the string is invalid. If the first symbol is 1, that is valid, but we need to check second symbol and third symbol also. So, Q1. If the second symbol is 0, I can go to next state. If the second symbol is 1, that is invalid, I can go to dead state. Third symbol must be 1, I can go to final state. If the third symbol is 0, that is invalid. So, once you reach dead state, for any number of zeros and ones, stay in the same state, D, dead state. Once you reach final state, that is, we have seen first three symbols in the order 101. Afterwards, the combination of any zeros and ones. You can read as many number of zeros and ones as possible. This is the transition diagram. Transition table is Q naught is the initial state, input is 0, 1. Q naught on 0 going to dead state, Q naught on 1 going to Q1, Q1 on 0 going to Q2, on 1 going to dead state, Q2 on 0 going to dead state, on 1 going to QF, then QF on 0 and 1 going to same state QF, then dead state Once you reach dead state, for any number of zeros and ones, stay in the same state. QF is the final state. Next, draw a DFA that accepts a language L over input alphabet sigma is equal to 0, 1 such that L is the set of all strings starting with 0, 0. The first two symbols must be 0, 0. Afterwards, any combination of zeros and ones. So, valid strings 0, 0, remaining any combination is a valid. 0, 0, 0, 0, 0 is a valid. Invalid are 1, 0 in 0, 0, 0, 0. 0, 1 is invalid. 1, 1 is invalid. These are all invalid strings. The first symbol must be 0. Second symbol must be 0. First symbol is 0. I can go to next state. If the first symbol is 1, there itself we can decide that the string is invalid. So, I can go to dead state. Once you reach dead state, for any symbol of zeros and ones, stay in the same state. So, by seeing first symbol, we cannot decide the string is valid or invalid. We have to check second symbol also. We can check second symbol in Q1. If the second symbol is also 0, I can go to final state. There you can read any number of zeros and ones, stay in the final state, because only condition is first two symbols must be 0, 0. Afterwards, any combination of zeros and ones. Then in Q1, second symbol as 1, you can go to dead state, because in DFA, for every state, every input symbol, we need to define the transition. For Q0, we have defined the two transitions 0 and 1. Q1, you have defined the transition for 0 and 1. For Q2, define transition for 0 and 1. Dead state also we define the transition for 0 and 1. So, this is the DFA diagram for the DFA for the language over input alphabet 0, 1 such that L is the set of all strings starting with 0, 1. Transition diagram, transition table is like this 0, 1. Initial state is Q0, Q0 on 0, Q1, Q0 on 1 dead state, Q1 on 0, Q2, Q1 on 1 dead state, Q2 on 0, Q2, Q2 on 1, Q2, dead state on 0, dead state on 1 dead state. Q2 is the final state. So, take one sample example, string processing delta. Initial state is Q0. Take a valid string 0, 0, 1, 1, because this is valid, first two symbols are 0, 0. Q0 on 0 going to Q1, remaining input 0, 1, 1. Q1 on 0 going to Q2, remaining input is 2, 1, 1. Q2 on 1, Q2, Q2 on 1, Q2. Q2 is the final state. So, DFA M is equals to Q sigma delta Q0 F. Q is set of states Q0, Q1, Q2 dead state. Input is alphabet 0, 1. Q0 is the initial state. F is the set of final state, that is only one final state, that is Q2. Next, construct a DFA that accepts a language L over input alphabet sigma is equal to A, comma B such that L is the set of all strings starting with A, B, A. The first three symbols must be A, B, A. Remaining input string anything. So, initial state is Q0, Q0 on A going to Q1, on B going to dead state, as the string should begin with A. Second symbol must be B, I can go to Q2. If the second symbol is A, going to dead state. If the third symbol is A, I can go to final state. In Q2, if you read B, go to dead state. Once you reach final state, for any number of A's and B's, stay in the same state. This is a DFA for a string starting with A, B, A. Construct a DFA that accepts a language L over input alphabet sigma is equal to A, comma B such that L is the set of all strings starting with AA or BB. Here the string begin with either AA or BB. After that, rest of the string may be combination combination of A's and B's. That means invalid strings are, the string should begin with either AA or BB, that is AB is all invalid. The first symbols are AB followed by anything is invalid. If the first combination is VA, that is invalid. So only the string begin with either BAA or BB. For that we need to draw the transition diagram. So initial state is Q0. If we need to define transition function for Q0 for input A as well as B. If the input is first symbol is A, I can go to next state Q1 because the string begin with A or BB. The first symbol A, if the first symbol is A, second symbol must be A. If the first symbol is B, second symbol must be B. See, if the first symbol is A, second symbol must be A. I can go to final state. If the first symbol is B, second symbol must be B. If the first symbol is A, second symbol must be A. If the first symbol is B, second symbol must be B. Once you reach final state, afterwards anything A or B, you can read any number of A's or B. But here Q1, you need to define transition for B also. In Q2, you need to define transition for A also. In Q1, that means the first, we have seen previous symbol A, that is first symbol is A. The second symbol we expect A. Instead of A, we can get another symbol, that is B. That is, it becomes AB. Previous symbol is A, current symbol is B, that is AB. AB is invalid. So that I can go to dead state. In Q2 also you have to define transition for A. That means previous symbol is B, current symbol is A, that is BA. BA is invalid. So that go to dead state. Once you reach dead state, for any number of A's and B's, stay in the dead state. You cannot come out from the dead state. So transition diagram Q0, Q1, Q2, QF. QF is the final state, Q0 is the initial state, input is A or B. Q0 on A going to Q1, Q0 on B going to Q2, Q1 on A going to QF, Q1 on B going to dead state, Q2 on A, this is A not B, BA going to, first symbol is B, second symbol is A, I can go to dead state. Q2 on A going to dead state, Q2 on B going to final state, QF on A same state, QF on B same state. Then take a sample string, Q0 is the initial state, take BB, AB is a valid string processing, Q0 on B going to Q2, this is first, remaining input is BAB, Q2 on B going to QF, remaining input is AB, QF on A, QF, remaining input is B, QF on B, QF, final state. So after processing entire input, if we reach final state, the string is accepted. That means string is accepted. So DFA M is equals to Q sigma delta Q0 F. Q is set of states Q0, Q1, Q2, dead state at QF. Input alphabet sigma is equals to A comma B. Initial state is Q0. Transition function Q cross sigma to Q. Final state is set of final state QF. Thank you.